Section 4.7, Inverse Matrices and Systems. In this section, we're going to look at how to use our matrices that we've been working on in Chapter 4 to solve systems of equations that we talked about in Chapter 3. In Chapter 3, we talked about solving systems of equations involving 2 equations and 2 variables, or even 3 equations and 3 variables, by using one of 3 methods. We either used graphing, substitution, or elimination. In this section, I'm going to give you a 4th method using a matrix equation to solve the system. So we have in previous sections talked about how to solve a matrix equation similar to the one that I have here on my screen. But what we need to do is we need to translate that system of equations into a matrix equation. Okay, so we're going to do that by setting up 3 things. We're going to set up what we call a coefficient matrix, a variable matrix, and a constant matrix. And if you notice, we're going to make some correlations here between our two. If you look over here at my 2 equations in my system, you'll notice that the coefficients of my variables translate to what I call my coefficient matrix. So we're going to call this first one, oops, let me spell that right, our coefficient matrix. Okay, this matrix I create by taking simply the coefficients out of my equations and putting them into a matrix. Okay, then as you can probably tell, the second matrix that I'm going to multiply here is called my variable matrix. This is going to be the matrix that holds the variables for my equation. And then finally, my last matrix is called the constant matrix. This is the matrix that holds the numbers that would be the solutions or the constants in my equations in my system. So I'm going to set up this equation from my system to a matrix equation, and then I'm going to solve this matrix equation to actually find the ordered pair where these 2 particular lines would intersect. Okay, so let's look at how that would happen. So if I take my matrix equation, which we talked about, we've got my coefficient matrix here, which is A, and my variable matrix X, and my constant matrix B. So you remember in the previous section we set up our equation A times X equals B. So to solve that equation, just like I had before, A times X equals B, I multiply both sides of my equation times my inverse, which over on the left-hand side, the A inverse times A gives me the identity, and the identity times X is just X. So what I find out is, just like a normal matrix equation involving multiplication, is that X is equal to A inverse times B. So I'm going to use my graphing calculator to actually calculate this. So I'm going to take just a second here and I'm going to switch out of this and go to my graphing calculator. Open that up real quick. Okay, so I'm going to enter my matrix into my calculator. So I'm going to go into the matrix menu. Let me put this screen up here so you can follow a little better. I'm going to go into my matrix menu and I'm going to enter my matrices. So I go over to Edit. I'm going to enter matrix A, which is a 2 by 2 matrix. So 2 by 2. And I enter my numbers. So my numbers are 1, 2, 3, and 5. Okay, so then I'm done with that matrix, and I'm going to enter my second matrix as matrix B, and this one happens to be a 2 by 1, and those numbers would be 5 and 14. Enter. Okay, so now I'm going to tell my calculator to do the calculation of A inverse times B. So I go into my matrices, I choose matrix A, and I want it to calculate the inverse times matrix B. And I hit enter, and I get this matrix right here, 3, 1. So now if I head back to my notes here, I was solving this matrix, so I came up with the solution that x is equal to the matrix 3, 1. However, as we talked about previously in chapter 3, this is a method for solving this system. The solution to this system is actually an ordered pair. So since 3 corresponds with the x and 1 corresponds with the y, I'm going to write my ordered pair solution as 3, 1. So we are solving a system, we're just using matrices as the method to do so. So I still want to give my answer as an ordered pair like I always have. Okay, so we're going to do a couple of examples. So we're going to do a system with 2 equations, 2 variables, and then we're actually also going to do one with 3 equations and 3 variables. So let's start with this first one. It says we need to write our system as a matrix equation and solve, and identify our coefficient, our variable, and our constant matrices. So let's start that here. All right, so I'm going to start with my first problem here. I'm going to set up my coefficient matrix. So I go through the coefficients in my equation, and I get a 5 and a 3 and a 3 and a 2. So this would be my coefficient matrix times my variable matrix. Now in this matrix, my variables are going to be the variables A and B, and those will go vertically like this, 2 rows, 1 column, equals my constant, so we'll call this one the variable, and then my constant matrix has a 7 and a 5. That would be what my 2 equations are equal to. Okay, so I'm going to set that up, and I'm going to solve that particular problem by calling this matrix A, and this matrix B, and this matrix X, right? And then I will solve that by taking the inverse of A times B. So I'll get my matrix here, and I'll get my graphing calculator out. So I want to do this. To my graphing calculator, go into my matrices, edit matrix A. Okay, so matrix A is going to be a 2 by 2 matrix, so that's okay. And then I enter my numbers, 5, 3, 3, and 2. Go over to edit, and I'm going to edit B. And this is a 2 by 1 matrix, and these numbers are 7 and 5. Okay, so I'm going to ask it to multiply matrix A inverse times matrix B, and I get the matrix negative 1, 4. So let's go back to our problem here. And my matrix is the matrix negative 1, 4. Now again, this was a system of equations. I'm looking for that ordered pair. So I'm going to say that that is negative 1, 4, alphabetically A, B, negative 1, 4. Okay, or in this case, since you're using A and B, if you want to tell me that A is negative 1 and B is 4, that would be fine as well. Okay, so now let's go over here to this system of 3 equations and 3 variables, which some of you felt was extremely tedious as far as the work is concerned. So we're going to set this up in a matrix equation. Again, a coefficient matrix, a variable matrix, and a constant matrix. So if I have a 3 equation, 3 variable, that means I'm going to start with a 3 by 3 matrix. So my first row is my first set of coefficients, a 1, a 1, and a 1. Then in the second row, I do my second equation, 2x plus y. So my coefficients are a 2, a 1, and since there's no z, that will be a 0. And then my third equation is a 1, a 3, and a negative 3. Okay, so there's my coefficient matrix. Then I'm going to do my variable matrix. My variables in this problem are x, y, and z. So that's the variable matrix. And then my constant matrix is 2, 5, and 14. Okay, so that is constant matrix there. All right, so now I'm ready to solve. And again, it's still A times X equals B. So X is going to be equal to the inverse of A times B. So when I find the matrix X, Y, Z, I'm going to be using my graphing calculator to do A inverse times B. So again, let's do that. So let's get out of here. Open my graphing calculator again. Go into my matrices. Go over to Edit Matrix A, which is now a 3 by 3 matrix. And I enter my numbers here. 1, 1, 1 for the first row. 2, 1, 0 for the second row, and 1, 3, -3 for the third row. Then I'm going to enter my matrix B, which is a 3 by 1 this time. And my numbers for matrix B are 2, 5, and 14. Okay, so I'm going to ask the calculator to do A inverse B one more time. Second matrix A inverse times second matrix B equals, and this time my values come out to be 1.25, 2.5, and -1.75. So I'm going to go back to my notes here, and I am going to put that into my matrix. 1.25, 2.5, and -1.75. Okay, so as an ordered triple, since this one actually is XYZ, this would be the point on the graph 1.25, 2.5, and -1.75. Okay, so you can use matrices to solve any system of equations. So if by chance I could even give you a system of 5 equations with 5 variables, you could set up your matrix equation and solve it with matrices rather than using elimination or substitution, which might take you an extremely long time to do so.